Good evening, students. My name is Darren Singh Patel, and we will continue operating system. So, what are we going to see today is synchronization. So, in past few classes, you have seen what are processes and what are the various operations related to it. So, let us revise that before moving forward to synchronization, because these topics will help us understand synchronization better. So you all know processes, right? And you all know all the operations of processes. So just hear me out. Just hear me out. You will understand everything. This is one of the most beautiful and interesting topic of operating system, and it is one of the most important topic as well. So you know processes. Okay. So what is preemption? Okay. So you know operating system. All the modern operating systems are they are multitasking as well as multi-programming in nature. So, what is multitasking and multi-programming? So, like you can use Facebook while you can also run your media player to hear the songs. So, you can use Facebook while listening to the music in your system, in your in your personal computer or in your laptop. So, that means you are using your operating system. So, this is multi-programming or multitasking. Okay. So, uh, what is preemption? So, in multitasking, all of these processes, for example, Facebook is one process, and your media player, your VLC media player, or any media player in which you are listening your song, is another process. So, both of these processes they came to your CPU or your processor in time sharing mode. So, in most of the operating system, it uses round robin scheduling. You all know that. So, what is preemption? So, this time sharing mode that 2 nanoseconds is assigned for one process, and after that 2 nanoseconds another process will schedule to your processor. So this alternative swapping of processes is actually we call it as preemption. So it is just a temporary stop. Preemption is just a temporary stop, and the process will come back and continue the remaining execution. Okay. And preemption can occur at any point of time. We have already seen in last classes. So why I am telling you this, let us see this example. So if you are using Windows operating system, so this is the screenshot of Windows operating system. So there are multiple processes running at the same time. So this is the screenshot, suppose at particular time. So you can see the VLC media player, these all of these processes. And how can you see that these all processes are running? So when you click on this detail tab, you all know, right? You all know how to open task manager. Okay, I'm giving you one shortcut. When you press control plus shift plus windows, sorry, plus escape, okay, plus escape in your Windows operating system, you will open task manager. And when you will go to details, this window will open. So you can see these all are the process and they all are running straight. So what I'm trying to tell you is in your Windows operating system, which is multitasking, multiple processes can run simultaneously. And since you have only one processor, so all of these processes share the processor in time sharing mode. Okay. So this is what I'm telling you. So since all of these processes are running, so according to the behavior, or we can divide these processes into two categories. In what two categories? So let me proceed. The concurrent processes executing in the operating system, in your operating system, may be either independent process or cooperating process. So what I was telling is, since let us see, this is one process. Okay, this is one process, this is another process. These all of these processes are belong to one software, which is Google Chrome. You must have heard of that. So since all those four processes belong to a same software, that means it is using the data of that particular software, yeah, that particular program of Google Chrome. So these processes are called cooperating processes. And let us say this is one another process, and it is not sharing any data with any other process, so we can call it as independent process. So there are two. This is independent, this is cooperating process. So you can see this. the concurrent processes executing in the operating system may be either independent or cooperating processes. A process is independent if it cannot affect or be affected by other processes executing in the system. Okay, so one process which is not affected by another process is independent process. So how do you understand, or how will you get to know that it is independent process? So any process that does not share any data with any other process is known as independent process. Meanwhile, what is cooperating process? So a process is cooperating if it can affect or be affected by other processes which is executing in the system. Or in indirect words, you can say any process that share its data with other process is known as cooperating process. So we have already seen. Okay, so why are we talking about cooperating processes? Because in synchronization, what our goal is, we want to provide an environment that allows process cooperation. What we want to provide an environment that allows process cooperation. What is process cooperation? So what we want is when one cooperating process is running and at the same time another cooperative process is also running, so the synchronization between them should be in such a way that no problem can occur. So why do we need synchronization? So that processes can communicate with each other effectively without causing any problem. So what is our today's topic? Our today's topic is synchronization. Let me give you another example. Let us suppose we are working in a band, music band. Okay, I am a singer and you are playing any instrument, and you are playing any instrument. Now I am singing a song and you are playing instrument with a delay of 5 seconds. So what will happen? Synchronization will definitely synchronization will not happen. So what problem will occur? People will start throwing eggs and tomatoes on us. Why? Because we are definitely singing very bad. That is why. Why? What is the problem? Because synchronization is not between us. So in same way, we need synchronization in cooperating processes so that so that no problem will occur. So tell me, what is the problem? How to know that there is a problem in synchronization, or so we will see one classical problem which is known as producer consumer problem in operating system, or also known as bounded buffer problem. You can write it as bounded buffer problem as well. Bounded buffer, it is also known as bounded buffer problem. Okay, so what is producer consumer or bounded buffer problem? We are going to see it, and we will see how, due to lack of synchronization, what problem we can face in our operating system. So let's see. So what is producer consumer problem? Let us first get acquainted with this problem. So two processes, producer and consumer, share a common fixed size buffer. What is buffer? You can say array. Just imagine we are talking about an array. So there are two processes. One is producer process and another one is consumer process. And they are sharing one array. Okay. Now what does producer do? Producer puts the information into the array and consumer takes the information out from the array. And acha, tell me, these processes are independent or cooperating? So they both share one common variable, which is count. So count is one variable which is shared by these processes, and buffer or array is also another data which is shared by both. So since they both the processes are sharing common data, that means they both are a cooperating process. Okay, and both the processes update the count variable. Okay, so this is the array. This is the array here. Producer puts the item and consumer takes the item out from here. So this is what the system is. Okay. Okay. So let us assume the buffer size is suppose 7. So from index 0 to index 6, there is an array. The total size of that array is 7. And producer is suppose consuming any item. So producer can it can produce 10, 12, 100, etc. item producer can produce, and consumer can consume this item. So it can consume here like 100, and then in next iteration it might consume 12, whatever. So there are few conditions that we have to follow. We will see it later. I just want you to understand that what is the problem. Okay, so this is the code. So count is the global variable because it has been shared by both the process. So we have declared it globally. I hope you must have a little bit knowledge of C programming. Otherwise, no problem. This is the easy code. You will understand. So this is the code for producer. There is no return type of producer, hence void, and there is also argument is also type of void. We are not giving any argument here. So int item p. Item p is the one variable which we are introducing in producer code in producer function. Okay. So while true means this condition will always be true. Now while count is equal to n. Okay, this is very intelligent logic they have used here. Now while count is equal to n is what? So what they want when the buffer is full, they don't want producer to produce any item at that time. So how they are going to do that? So we have assumed that Rn is what? Rn is suppose 7, which is the total size of the buffer. And count. What is count? Count is the variable. Okay, let me tell you what is count first. So this is our array. Count is the variable used by both producer and consumer to identify the number of items present in the buffer. So suppose right now there are 3 items in the buffer. Okay, so the value of count at that time will be 3. And n is the variable used by only producer to identify the next empty slot. So what is the next empty slot? Next empty slot is 3 right now. So at that time, the value of n will be 3. So that the next item that producer will produce will go into index number 3. Okay, so this is index number 3, or you can say fourth position. So we will say index number 3. And what is out? Out is the variable used by consumer to identify from where it has to consume the item. So from where the consumer has to consume the item, that value will come to out. So if consumer wants to consume the item from index 2, so they over there, the out value will be 2. Okay. So let us come back to the previous slide. We will understand the code now. So while count is equal to n, so let us say your count value is also 7. Your count value is also 7. Now 7 is equal to 7. What does that mean? That means while 7 is equal to 7, that means this condition is true. That means while condition is true. Now the while condition is true and here is semicolon. So what does it mean? That the entire process will stop here. Why the process will stop here? The entire process, because this condition is true. So when this condition is true, after checking this condition, your compiler will send the instruction back to while, and it will again check the condition. Now again the condition is true. Now it will follow the same loop. It will follow the same loop. So it will keep on rotating. It will keep on rotating in this loop because the condition is true. Or suppose the condition is false. If the condition will get false sometime, suppose count will get 6 later. So what will happen? Count now 6 is equal to 7. Is it true or false? If since it is false, then only the execution, then only your code will execute the next instruction. Otherwise the next instruction will never be executed. So this is what is the logic of this line. Okay. So in next line, what they have done, whatever the item p you have produced, they will they will put that item uh, into that buffer. Okay. And then they will increase the in. Why they have used mod n? Because they want the values in between from 0 to 6 or 0 to 7. Why so? Because our buffer is of fixed size. So after like 0, 1, 2, 3, 4, 5, and so let us say 6. So after the 7 value will occur, so what it will do? It will do 6 plus 1 mod, let us say 6. So 7 plus 6 is what? 7 plus 6 is 1. So what will happen? Again, the value will go to first place. Okay, so that is why they have used mod operator over here. Then they will increase the count value. Same as for consumer code. What will consumer do? Consumer will consume the item. So they have declared one variable item c while the condition is true. Now while count is equal to 0, what is the logic behind this line? So what they want when the buffer is empty, it count is what? Count is actually how many total items are there in buffer. So when the buffer is empty, consumer will not be able to consume any item. That is why this condition they have wrote. So when this condition will true, same, your execution will get halt, or the execution of that process will get halt. Why it will get halt? Because it will rotate in this line only, because this condition is true. So it is actually an example of infinite loop. So the execution will keep on rotating on this line. Now if this condition is false, then the execution will come to next line. Now what is it? Item c is equal to buffer of out. So whatever be the value of out. So buffer of out means that value at that position will come to item c. Now out is equal to out plus 1 more than, it will increase the out value, so the execution will go to next out value, and now it will reduce the count. So this is the code for consumer. Now let us proceed further. Okay, so we have already discussed this. Count is what? Count is the variable used by both producer and consumer to identify the total number of items present in the buffer at any point of time. And n is what? N is the variable which is used by producer to identify the next empty slot in the buffer. And out is what? Out is the variable used by consumer to identify from where it has to consume the data. Okay. So this is the code you have seen about producer, as well as you have seen the consumer. Okay, and this is the buffer. Now, now what we have to see, we have to identify the problem, which is we have to identify the problem which is taking place because of not having proper synchronization in between the cooperating process. Okay, so how are we going to identify it? So we will take the help of preemption here. But first let me tell you what first let me introduce you how the producer is producing an item. So okay, let us see the buffer is like 7. The total array size is 7. Okay, so we have index from 0 to 6. We have indexes from 0 to 6. Okay, so now producer is producing, let us say int item p. So let us say int item p right now is, since we are starting it, so the value of count is 0 right now, and the value of out is also 0 right now. Okay, because we have just started now void producer void int item p. So let us see, int item p is giving you the value 10. Okay, now while true, this condition is true, no problem. While count is less than n. So what is count right now? So you have not produced any item right now, so count value, the value of count is 0. The value of count is 0. Okay, so 0 is equal to 7. Condition is true or false? Condition is false. Condition is false. That means this while loop will not get executed. Now the execution will come to next line. Buffer in is equal to item p. It means what? The value of item p will get copied to your array. So let us buffer is this array. Okay, so buffer of 0 is equal to 10, because your item p is 10, and this is the 0th index. So this 10 will get copied to your 0th index of that array. So what is that a value? 10. So producer has produced one item in 0th index, बोले तो first position. What is the value? 10. Now it will update the count value. Count is equal to count plus 1. So it means your producer has successfully produced an item. Now it will say कि भैया array में एक item आ गया है. So it will say count is will get 1. Okay. Now let us say we want to again use the same. We again want to produce one more item. So let us say this time we are producing 20. So void producer void int item p. Now this time the value of item p is 20. Okay. So while condition is true, no problem. Now while count is what? Count is 1 now. So count is equal to 7. Condition is false. We will go to next instruction. Now now item p will get copied to the first index of buffer array. So what is item p right now? Item p is 20. So here 20 will get produced, and same it will increase the count value to 2, because right now there are 2 items that have been produced. Okay, now let us say a consumer is now we are going to run consumer code. Now what is consumer doing? Void consumer void int item c. So it has produced one item. it has produced one variable called item C, which is of integer type. Okay. Now while condition is true, this condition will always get true, no problem. Now while count is equal to 0, so is the count variable 0 right now? No, count variable is 2. So 2 is equal to 0. Condition is false, that means it will not get into infinite loop. Okay. Now buffer of out will get the value of buffer of out will get copied to item C. So what is the value of out here? 0. Okay, so buffer of out. Now buffer of out बोले तो buffer of out क्या है बफर ऑफ आउट में? तो बफर ऑफ आउट बोले तो बफर ऑफ जीरो में अभी 10 है. व्हाट इज द वैल्यू है? 10. सो दिस 10 विल गेट कॉपीड टू बफर आउट में अभी 10 है. सो दिस 10 विल गेट कॉपीड टू आइटम सी. सो आइटम सी की वैल्यू क्या हो जाएगी? व्हाट विल बी द वैल्यू ऑफ आइटम सी? 10. सो यार आइटम सी पर 10 हो जाएगा. Now it is incrementing out value. Out is equal to out plus 1 mod n. So out is equal to out plus 1. So 0 plus 1 is 1. 1 mod 7. 1 mod 7 is 1. No problem. So it will increment the out value. Now it will decrease since you have consumed one item. Since you have consumed one item, uh, so definitely the count variable will get updated because one item has been consumed from your array. Now the total items in your array will be 1. So it will again update the count value to 1. So this is how producer is going to produce and consumer is consuming one item. So right now what you have observed that this code is working fine. Now where is the problem? Sir, you were saying that uh, both of these processes are cooperating processes. So where is the problem? So we will see how the problem will get started. Okay. Okay. So we will have to go little bit detail of how the count variable will work. Why we are only seeing count variable? First of all, because this is the shared item. This is the shared item and it has been shared by both producer as well as consumer. Okay. So what we also call it as critical section. Okay. We will see critical section and all other important definitions in next class. Today just assume it, just write it down in your copy as critical section. Okay. So the value of count will get incremented in 3 micro instructions. How? So first of all, what will happen? You will see all these details in computer organization chapter, in computer organization subject. But anyways, I'm going to explain it. How the value of count will get incremented in? It will get incremented in 3 steps. How? First of all, first of all, there will be one register in your CPU. There will be one register which will load the count value. So how it going to load the count value? So load the register. Sorry. Yeah. What it will do? It will say, okay, the pen is not working good. Take one register. Take one register. Okay, so registers are in your processor. Okay, so take one register and load the count value into the register and load the count value into register. Okay, you have done it. Okay, so what is the count value? So let the count value is right now 3. So load this count value into this register. Okay, so you will say in first instruction, suppose you are using one register named RP. RP is one register. RP means it is the register for producer problem. So RP is the register and you have loaded 3 into it. Now increment the register value. So let us increment the register value. So in second step, you are going to increment the register value. So okay, I am going to increment the register value. So 3 plus 1 is 4. Now what is third step? Third step is store the updated register value into count variable. So store. So here you will say count is equal to 4. So this is how you have stored. So in these three micro instructions, you are going to update the count. Now, why I am going into these micro instructions? Because preemption, you have heard preemption, right? Operating system uses the processor in time sharing mode. That is what preemption is do. So, so preemption can take place at any point of time in executing any process. So we are talking about producer and consumer here particularly. So preemption can take place at any point of time. So your preemption can take place here, or your preemption can take place here, or your preemption can take place here. Anywhere preemption can take place. Now, sir, you will now the very general question is preemption can take place here also. Yes. Let me change the color of my pen. Just a minute. Yeah. Now your general doubt is, sir, preemption can take place here also. Yes, definitely. It can take place here also. Yes, it can take place here also. It can take place here also. So why you are taking preemption in between the count? So so all of these instructions are independent. Are they? Suppose item P is the value of item P is depending on your consumer? No. This code is also independent. This line is also independent. But count. But when we are talking about count, so count is not independent. Count is what? Count is shared by consumer. So that is why we are emphasizing on count. So why particularly you are taking here? So we will see. I will give you the answer of this problem after 2 to 3 minutes. Okay. The same three micro instruction will take place in reducing the value of count also. So what it is, take one register and load the count value into that register, and same decrement the count value by 1 and store the updated count value. Okay. So now we are going to observe. So this is one instance of your producer and consumer. So we have three values in count. Okay, let me just again change the color. Okay. So they are saying that there are already three values in your buffer. So let me say 10, 15 and 100. Okay. And your consumer has not consumed any item. Okay, no problem. So let us run the producer process first. Okay. So now producer is going to produce an item. Let us say this time it is producing 500. Condition is true while count is less than equal to, while count is equal to n. So what is this? What does that mean? What is the value of count right now? Count is 3. So 3 is equal to 7. Condition is true, no problem. Now item P will get stored in third value of third index of buffer. So what is here? It will get updated to 500. Okay. Now n is equal to n plus 1 mod n. So it will update the n value. Okay. So let us say it has updated the n value to 4. Okay. Now it will update the count value. So how will we update the count value? We will update the count value by using those three instructions, those three micro instructions. Now what it is saying? At first it is saying take one register and load the count value. Okay, so we have taken this register. Okay, we have taken this register and we have updated its value as what? 3, because count value is 3 right now. Okay, count value is 3. Okay. Now increment the register value. Okay, so in second step we have incremented the register value. Increment means incremented by 1. So we have incremented it as 4. Okay. Now I am taking preemption here. What I am taking? I am taking preemption here. Okay, so what does preemption do? Preemption will pause this process for a few minutes or for few microseconds, and it will give the execution to another process. Okay. So let us say we are going here. Now what does your consumer is doing? Let us say consumer has produced, so it has one item C. Okay, no problem. Now while this condition is true, now while count is equal to 0, what is the count? Count is 3 right now. Okay. And 3 is equal to 0. Is this condition true? No, false. So that means it will not go to infinite loop. Okay. It will also, this condition is false. Okay. Now it will come to a buffer out will get copied to item C. What is the value of out? Out is right now 0. So it is pointing to value 10. Now 10 will get copied to item C. Okay, so the updated value of item C is 10 now. Now it will update the count variable to 1 because 0 plus 1 is 1. So out is a 0 now. Now it is updating count value. So what is count? How it will going to update the count value? By using these three micro instructions. So if what it is saying, take the count value. Okay, we have taken the count value 3. Now take one register and load the count value to in it. Okay. So suppose Rn is the register. Now they have loaded the count value 3 to it. Okay, sorry. What is this? Okay, so they have, okay. So I'm sorry for the delay. Where were we? अरे भैया. Okay. So yeah, we were where? Okay, actually my pen is not working very smooth right now. That is why this interrupt happened. So this is also an example of synchronization. Because of this problem, this synchronization error happened. Okay, so this was I have not done it deliberately, but yeah, it is also again a problem of synchronization. Okay, so where were we? We were updating the first micro instruction. So take the count value and take the count value and load it into register Rn. So we have updated the register Rn as 3 right now. Now decrement Rn. So let us decrement it. So we will decrement it by 1. So now the value of it is 2. Okay. And they have taken this and now decrement the count value because you have taken the first value to item C. Okay, to item C. Now you have also decremented it. Now store the count value to, now store the register value to count. Okay. So what is the count value right now? So count value is according to your count is equal to count minus 1. Your count value is now 2. Okay. Now, now it is showing what? Now this process get finished. Now since the preemption took place from here, this process, this complete consumer process has finished completely. Okay. Now the execution will come to producer. Why? Because it got preempted. Okay, so when the process gets preempted, definitely execution comes to it after some time. So now the execution is now came to producer process. So where that process was stopped, that process was stopped here. Now sir, how do you know that process was stopped here? Because in every micro instruction they also maintain one variable called program counter. Okay, so program counter will tell you where that problem got stopped. So over here that problem got stored. Now it is saying what? Store the updated register value to count variable. Now what is the updated register value? Updated register value was 4. So update 4 here. So I am updating 4 now. Now tell me. Now tell me how many values are there in your buffer. So since this 10 was consumed by consumer, so actually there are only three data values in your buffer. What for? 15, 100 and 500. And now what is your count showing? Your count is showing that there are four values here. Now you got me? Your count is saying that there are four values in your buffer, in your array or in your buffer. But actually there are only three processes. There are only three data. What? In your index 1, in your index 2 and in your index 3. So this is data inconsistency. So why this data inconsistency took place? This data inconsistency came into existence because of not having proper synchronization between your producer and consumer processes, because at some point preemption took place. That is why. So this is one of the most commonly used example of synchronization, as it is known as producer consumer problem. So this is also one of the classic problems. So this is what is the problem, just because not having synchronization. Now your most common doubt is why you took preemption over here. So भाई मुझे ये बताना था कि इस प्रोड्यूसर कंज्यूमर वाले कोड में प्रॉब्लम कहाँ आ सकती थी। तो मैंने काफी हर जगह मैंने ट्राई किया कि ये प्रॉब्लम कहाँ आ सकती है। अब मैं ये आपसे पूछूं, फॉर एग्जांपल इफ आई एम आस्किंग यू कि सपोज यू आर हैविंग fight with your friend. Okay, okay, let me give you one example. Suppose you have one friend named A and you have another friend named C. Now you are going to meet A at 10 a.m. Okay, and it will take you around 10 a.m. to 11 a.m. Now A and C are enemies in between. Okay, and you have invited C at 11 a.m. and you have invited C at 11 a.m. So you thought कि you will meet A for 1 hour and after that you will say Tata to A and you will then meet to your second friend C for 1 hour. But now, so is there any problem? And A and C both are enemies. So when they will meet to each other, then definitely they will create chaos. So there is one possibility. There is one slight possibility that your meeting with A will get extended by 10 minutes. So at 11:10 you are still standing with your friend A, and over there is slight possibility, okay, and we are talking about possibilities here. And at 11 a.m. your friend C came. So now what will happen? They will they will meet each other, and when they will meet each other they will fight. So this is what you wanted to avoid, but the fight eventually will took place. So there was a possibility of fighting, and you have created this possibility, okay. So same way, there a possibility of having a problem in synchronization. So yes, there was a possibility, so we just found out that possibility here. So how did you find out? You did find out by taking preemption over here. So this is what I wanted to explain in this session. So in tomorrow's class, we will further see producer and consumer, and we will see what is critical section and other related information. Okay, so thank you, student. Thank you very much. See you in next class.